Alright, so what would be your next check? Now we have to focus on the mass airflow sensor. Now this is a volume airflow sensor. It's this big honking thing right here. You can see there's a flapper in there. As more air comes in, basically the flap opens and the little potentiometer reads more. On the diagram, it's right here. And it also incorporates a fuel cut switch. So if the airflow is too low, it cuts the power to the fuel pump. That's interesting. Maybe that's why the car is dying. And when you start it back up, there's a second winding in here. It comes from the starter to energize the pump while you're cranking. And when it when the engine spins and starts up, this closes and energizes this part of the relay, keep the fuel pump running. So the potentiometer here is pin 4 on connector S, yellow and blue wire. So I want to scope that and the oxygen sensor and maybe injector pulse width. Gather some more data, and then while it's still running close to idle, we can do an ignition timing check just to rule that out. An ignition timing procedure, it's pretty simple. Adjustments, ignition. Again, you install the jumper wire to set it into base timing, and it should be 10 degrees before top dead center. That agrees with the information here. It says don't touch the idle mixture screw. Ignition timing 10 degrees with check connector shorted at idle. You probably can't see that. Idle speed 800 RPM. So let me connect the scope to the appropriate spots, and we'll get the old school timing light out, double check the ignition timing. Alright, so I moved some channels around. So number 1 still is on IGT. I want to monitor the RPMs of the engine so we know exactly when it stalls out. Channel 2 is now on pin 4, connector S, yellow and blue wire. That's the airflow measurement. Channel 3 is still on the oxygen sensor, and channel 4 is on this green and red wire at the circuit opening relay, which goes to this fuel cut switch. So if that switch opens, we'll see high voltage here, and we know the fuel pump cut out, and that's why the car is stalling. So let's do that experiment. Alright, so we got the scope rolling, and as soon as the car starts, I'm going to connect the jumper and do a quick timing measurement before the car stalls out. That didn't last very long. Can we get more air to here? Let's see. So we're at 3 1/4. Let's do 4. 4 1/4. Scope is rolling. What the heck is channel 4 doing? Went from low to high very slowly. Okay, I thought it was just a switch. Come on, come on. Jeez, really doesn't want to stay running. And the switch went high. Okay. Let's stop that recording and save that data, but I can't keep the car running to do an ignition timing measurement. Alright, so I have a little tool propping the throttle open a bit. Let's see what happens here. want to start now. Let's scope the injector pulse width just for kicks. Alright, I moved channel 3 from the oxygen sensor to injector number 4. Just want to see the pulse width, what happens when it's running and right before it dies. So let me start it up again. Keep it running with the throttle. Okay, so it's almost like it ran out of fuel, isn't it? There's the injector pulse width. Now I should have, my channel settings were wrong. But we can still see the pulse width. So let's see, I started up, revved up, let's get a baseline. Pulse width was, measure the delta here, 2.9, about 3 milliseconds right there. Okay, as we're stalling out, what's the pulse width right here? 3.5 milliseconds. So I guess if fuel cuts when I let go of the accelerator. .8 milliseconds. You might fire it. You know, there's a fatter pulse width. Then a fuel cut again. And finally, right before it stalled out, we were at 3.8 milliseconds. The vane airflow was at 7 volts. Now it was at 7 volts consistent, and you see when I revved it up right here, it goes up a little bit. 8.8, 7.5. Okay, this is a pretty cool capture. But then right here, when it drops off, and the fuel, you know, basically stalls out and it cuts the fuel pump. So the fuel pump's running all the way through the stall. Let's measure fuel pressure. Need a gauge for that. Alright, so we have fuel pressure specs here with fuel pressure regulator vacuum hose disconnected, about 35 psi, with the hose connected, 25 psi, and fuel pressure regulator is right there under the throttle linkage. There's a vacuum line that comes here to this little solenoid. Now, the solenoid should be normally connected through this fuel line, and then that goes to the intake vacuum. Now this solenoid is, you see right here, this VSV, there's a fuel pressure regulator, that's with air conditioning. Okay? So we can easily disconnect this line and then reconnect it and see if the fuel pressure goes up and down. We need to connect the fuel pressure gauge to that fuel filter over there with a special adapter. Alright, took a few minutes to install the fuel pressure gauge. With the SU-R&R kit, had the Toyota fuel filter adapter, so you can see that screws in instead of the original banjo bolt with 2 rubber washers, and the fuel gauge just plumbs right in. Let's fire it up, see what the fuel pressure reading is, you know, while it's running, and then unhook that vacuum line, see what happens. look at the gauge. Yeah, we're at 35. Let's put it right here. That should be plenty to start. 40 psi. Okay, I think we're just about there. So check this out. I'm cranking the engine here, and the IGT signal is at 0 volts, and then we get 3 firing events and stalls out. Then right here, crank, 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 it's injecting fuel, and then brrr, and then it catches and it runs. And check this out. The spark drops out before, there's one more injector pulse, and then finally the airflow drops out and we're done. So is the spark being lost during this event? That's pretty nuts. So we know the fuel cut works. We don't really care about that, and it's synchronous with when the red drops off, the fuel cut comes on. So we don't need channel 4 on that anymore. Let's put channel 4 on a spark plug wire to see if the spark is actually, if that IGT signal is directly related to the spark occurring. So I'm looking at the previous recording, and again, why do we have so many injector pulse widths before the IGT decides to come online? And it fires up, rev it up right here. IGT is perfect. There's a fuel cut, that's good. And right here, boom, you lose spark, and obviously the engine keeps spinning for a little bit. We get one more injector pulse, and then we drop out. So is the computer, for some reason, losing the ability to send ignition timing pulses to the distributor? So back to the drawing board here. Now we're focused on ignition. So you can see how many things we've went through already. Now we're focused on spark. So IGT, that's the one that tells igniter when to fire. So I want to put, so we'll leave that channel 1 on there, and let's see here, distributor, that's a distributor, G1, G minus G plus. So NE must be, there's a crank, kind of a crank and cam signal, I guess. So G minus G plus, we can use the channel for that. See what that's doing. That's coming from the distributor, and the NE. Let's go back to that. We can even see one of the older. Let's see here. File, open, stall warm. So we didn't quite pay attention to what drops out right as it stalls. Look at that. NE goes all the way. The red is NE. The yellow is IGF, goes all the way. IGT stops right there. If IGT stops, you're dead in the water. And that's the computer sending out that pulse. Okay? So NE and then IGF. So how did IGF fire? So it must be, it sees the pulse and it goes, another 1, 2, 3, 4. And then it doesn't see an IGT anymore, and we're dead in the water. So this is a really cool capture. We didn't notice this before. IGT is dropping out. when this car's warm. That kind of blows my mind. Now, is that a pull up or a pull down design? 0 to 4.5 volts. That's definitely coming from the computer to the distributor. But is the computer pulling that down, or is the distributor, or is the computer sending out a pulse to the distributor? So, very interesting. And we need to scope. We don't know the strategy here. We need to scope this G minus and G plus at the engine computer. So, connector T, pins 3 and 4, black and white wires. Here's another theory. This G minus and G plus, that must be a variable reluctance type sensor. And these are all digital. So when hot at low RPM, that signal could be getting a little too weak, and boom, the car stalls out. At high RPMs, signal's strong enough, we have no problems. So in this case, I'm not suspecting a computer problem. I'm suspecting this variable reluctance type sensor is just heating up and getting weak. We need to prove that with a scope. Alright, new setup here. So we got channel 1 IGT, channel 2 IGF. That's a confirmation that a spark occurred. C is injector 1, and D is that G distributor right here. So I have the scope leads on the Pico. We have isolated grounds. So I just have the yellow channel across 3 and 4. Right here. 3 and 4. So now let's run it, see what happens. Alright, here we go. Okay. Got a nice capture there. Let's zoom in. So I'm interested in this amplitude. That's kind of like the crank signal. Delta is about 2.4 volts. You can see right here, IGT just shut off. And the IGF kept going. Spark. So it's always 1, 2, 3 sparks, and then we're done. So I think this is too weak. When we first revved it up, let's get this injector out of the way. We were at plus or minus 10 volts. Car's happy. And right here, it's, look how small that signal's getting. So apparently 2 volts is just not enough, that little spike, for the IGT to continue. I think that's what's going on here. We can try disconnecting that G signal altogether and see if the car even starts or runs. You know, where's the first IGT signal here? Right here. But the spark, actually the spark is occurring way earlier. Spark, 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 spark. So maybe the computer just takes over ignition timing right here. Maybe I'm not quite correct on if there's no IGT, there's no spark. Because obviously there's a spark here. And there's a injector pulse. No IGT until we get to here. Yeah, very interesting. Alright, so doing a quick visual inspection here. on the distributor there is a plug that comes out right here, and then there's two green connectors. One is the white with black, that's the G signal, that's the one we're scoping, and there's also a white and red wire coming in to here. There's a white and a pink, and that goes directly to our ignition coil and igniter assembly. Right here, the white and the pink. So, my question is, what are we not seeing on the wiring diagram? Look, there's a little mini fan there too. We're not seeing this pink and white wire going directly from the distributor to the ignition coil. That's just a high tension lead. Goes to the distributor. We got G1 and G, minus and plus, that's there. What about from here to here to the igniter? We don't see that. The igniter has, here it just has 1, 2, 3, 4 wires. Here he has 1, 2, 3, 4, 5, 6, 7, 8 wires. Do we have an incomplete wiring diagram? So with the G signal unplugged, let's see if the car starts and runs. It might not. Check engine lights on because the G signal is missing. Okay, let's take a look at that capture. Okay, so with the G signal unplugged, what difference do you see? Now, the injector is pulsing every 2 ignition coiling firing events versus every 4. So that G signal is just to synchronize the 2 sets of fuel injectors. They're batch fired, as we see on our diagram right here. Injectors 1 and 2 are fired together, and 3 and 4. If there's no G signal, then they're just fired all at the same time. So that makes sense. So the only other RPM pickup is those 2 wires that go directly to the igniter from the distributor. Let's put a scope on those. We don't know what they are, but we need a good signal. Alright, so channel 3, I moved from the injector control wire to this mystery pair. I assume it's a variable reluctance type sensor. It comes from the distributor right to the igniter. So I want to see what that's doing. Alright, here we go again. Okay. Alright, let's take a look at this data. So the G signal's plugged back in, that's the yellow spikes. And then this is the mystery, not on the wiring diagram, that goes from the distributor to the igniter. You can see the amplitudes are pretty much the same, and the ignition coil fires boom, boom, boom on every one of these green humps. Okay. And then the IGT kicks in after whatever, a certain number of revolutions and starts controlling the spark timing. It's fine. The green trace doesn't drop out. I mean, the engine's stalling right here. Slowing down, slowing down, slowing down. You see the amplitude's dropping. But the ignition seems to be still fine up until it stumbles and drops out. If it's getting fuel and has spark, why the heck would it just stall out like that? I don't understand. It seems to run really smooth, fine, and then and then cuts out. Especially when warm. You know, it's not an EGR problem. It's definitely not an EGR problem. Otherwise, it would stumble and carry on even at a little higher RPM. Something's just shutting off. Fuel pressure is maintained. Could we have shorted fuel injectors that aren't actually opening and closing? So let me save this, and we'll put channel 4 back on a fuel injector. Look at the pintle humps. We can compare injector driver 1 to injector driver 2. Look at the current on the two wires. That's a good thing to do. Next experiment, let's focus on these fuel injectors. So those are the two control wires, the blue and the yellow. So I have two channels dedicated to measure the voltage on those, and then an amp clamp around both wires. So the red channel is still going to be our IGF, make sure the ignition coil is firing. Then injector current, injector pair 1, injector pair 2. Let's see what happens. Alright, here we go. Let me, let's see here. There's the green, there's the yellow. They're both on plus and minus 20 volts. Why is the green? See, green's going down to 0. Yellow's, oh, because of my scale here. Yeah, that's a little better. Okay, so those are the two injector pairs. We can even put them on one line here. That's 0. That's 0. They look nice and even. There's the current. The current is also even. Can we see pintle humps? We'll have to zoom in a little bit. And when it stalled out, nothing crazy happened. Injectors were still firing. Pulse width did not change. So now this is getting more interesting, isn't it? What would be your next check?